Let's talk about electrical circuits. While checking for a no-start condition, the ignition coil has 0 volts on the input side and ground side of the ignition coil. If the circuit has a fuse, go check the fuse to confirm it's not blown, since this will be the easiest component to check. At this point there is no need to check the ground circuit because the component is not receiving voltage. For example, if the input side of the circuit has a connector ahead of the coil, C146, and the connector has no voltage to it, now it's time to trace the circuit towards the voltage source, and that's usually towards the battery, ignition, or fuse. Once the open is found, repair it and recheck the power or voltage to the input side of the circuit. In this case it would be the ignition coil. In a parallel electrical circuit, there are 2 individual paths to the ground, unlike a series circuit. Here is an example of a parallel circuit. The engine starts and runs while the ignition switch is in the start position. However, when the ignition switch is allowed to return to the run position, the engine stops. If you examine the circuit on most schematics, the run and start positions are parallel circuits. Look for the voltage source for the run position because it's parallel to the start position. Your first check should be the fuse or voltage source. Remember, when one parallel circuit fails, the other circuits can still function normally. If there is a constant source voltage reading of the ground side of the circuit for a non-operative circuit, the next voltage check should be at the ground control side of that circuit. Keep in mind, if there is source voltage on the ground side of the circuit, you have no ground. A good example would be if the ignition coil has system voltage on the ground side of the circuit and it's a no start. Your next step would be to check the ground control circuit or trigger from the control unit. Remember, when a circuit has individual paths to the ground, it's called a parallel circuit. Let's talk about the engine coolant temperature circuit, ECT. The ECT temperature reading by the PCM is reading a -40 degrees Fahrenheit. What can cause this condition? An open 5-volt feed circuit to the sensor. An open ground circuit from the sensor. An open engine coolant temperature sensor. Let's talk about the throttle position sensor, TPS. There is a 0 voltage reading on the scan tool from the throttle position sensor. This can be due to open 5-volt feed wire, open throttle position sensor, open signal wire from the throttle position sensor. Let's talk about the intake air temperature circuit, IAT. On the IAT sensor circuit, the PCM is reading a 5-volt signal. This can be caused by an open in the sensor 5-volt feed circuit to the intake air temperature sensor, where the PCM is only reading the feed voltage, which is 5 volts. An open within or in the intake air temperature sensor can also cause this condition. An open ground wire from the intake air temperature sensor will also cause the PCM to see 5 volts on the signal line. Remember, the 5-volt reference voltage to most sensors is supplied by PCM. Let's talk about the fuel pump relay circuit. The fuel pump relay is inoperative and the fuel pump doesn't work. Remember, relays have 2 circuits. If either circuit, contact points or coil windings, doesn't receive any voltage supply, the circuit will be inoperative. The points or contact side of the relay is usually the load or high amperage circuit. The coil or control side is the low amperage circuit. Each circuit of the relay has an individual function. Remember, the control side of the relay must function first. Once the coil is energized and the magnetic field is built around the coil, the contact points on the load side of the relay will engage. This action will send voltage to the load in the circuit to function. Remember, both sides of the relay need system voltage for the circuit to work. If there are 2 relays in a circuit, for example PCM power relay and fuel pump relay feeding individual components in that circuit, they are most likely in parallel to each other. In an electrical schematic, if the PCM is receiving voltage from a component, most likely the PCM, the power control module, is supplying the grounds to those various circuits. Series circuit. If the inertia fuel shutoff is in series to the fuel pump, and if the inertia fuel shut has an open, and it is in series with the fuel pump will not engage. The fuel pump circuit will receive 0 volts and the vehicle will not start. Remember, there is no current flow in an open circuit and current is the work. Remember, a relay operates a component in an electrical circuit. When that relay is energized, that component should receive system voltage. The same is also true if the power train control module supplies a ground to a circuit or component, and once the ground is energized, or engaged, that component should be energized. If the PCM or power train control module doesn't supply the ground, there will be system voltage at the PCM terminal. Remember, when the relays are energized, they should supply system voltage to the component in that circuit. Thank you for watching. Any questions, please contact the instructor.